And I will use the opportunity to tell those of you on the call, if you are working on an interesting project, or if you yourself, if you are doing something interesting, feel free to send us a message. Either myself, Finley, and Dr. Wilson, we will support you to present it during this meetup event. Just a brief introduction of myself. My name is Emmanuel. My first time in this meetup group is in 2018. Then we used to do it face-to-face. I still hope that we'll go back to face-to-face of sometime. I hope that we are going to organize a face-to-face event in Glasgow. Although definitely having this online has helped many people to join from all over the world as well. This group is dedicated, is ML Group Glasgow, Machine Learning Group. And what we do is helping new people to get into machine learning. The group is beginner friendly. Although you don't have the privilege now, when we used to do face-to-face in Glasgow, all you do is you go there with your laptop, and you see a group of guys coming in, some coming from work, others coming from uni. There's a central, people continue working on the same problem on their computer. And if you have a problem, you talk to the next person. So it's like, sometimes it's something like a study group. But now we don't have that, but we are having more session and more talk around this. I hope as much as possible, we are able to support each other in our journey. So that is me. In terms of work, I've worked as a data analyst, data scientist. Currently, I'm into data engineering. I enjoy almost every aspect of data. You know, in data science, or there are so many roles. So one size doesn't fit all. So as you are coming today, be open-minded. There are different things you can do that relates to data. Today, our focus is on machine learning algorithm. Which model should I use? This is a very popular question for some of you that you've been building your own model. At some point in time, you would have experienced this problem, choosing which model you should use. And next, I'm going to show you our outline for today. Today, there will be a brief introduction about machine learning. I'm going to briefly talk about the types of ML algorithm. We'll talk about choosing the right algorithm. We'll talk about the best practices for implementing machine learning algorithm, and then we are going to be arriving at a conclusion together. So on introduction, let's look at machine learning concepts. You know, in machine learning, what bring about algorithm in machine learning is that usually in your machine learning, you always have a problem. If you look at this image, you always have a problem. And in order for you to actually make a decision on your machine learning, it starts from what kind of problem you are trying to solve. For those of you that you might be a bit new to machine learning is an aspect of AI. I'm sure you've heard about ChatGPT. There is image diffusion. There are so many cool things that is going on at the moment with machine learning. So, but the basic concept of it is actually for machine learning, there is usually there will be some data. And what a machine learning model does is it tries to learn from the model, and based on the model's understanding of the data, that's what guides the model's decision in making, that's what guides the model in making the decision. Please, I'll request that if you are not contributing, please kindly mute yourself. So as I said, that's what guides the decision of the model. Generally for machine learning, sometimes you already know the type of outcome that you want. And sometimes you get this outcome through your training data. An example is if you have, let's assume you have a data that includes history or bank customer history in a bank. It includes maybe a history of customers that have applied for a credit card. Probably such history we have people that have been rejected and also people that have been accepted. In that case, the machine learning model can be trained based on either people have been accepted or rejected. In that case, we call it is supervised because there is an outcome. There's an outcome of either being accepted or rejected. And in some cases, you can have scenarios where there is no outcome, and such example is like segmentation. Maybe you just have a huge amount of customers and you have the data sets and you want to group your customers into maybe high purchasing customer or low purchasing customer. You can group them based on the amount of, based on their spending. So you can group maybe customers that have bought, maybe people that have purchased maybe between 50 to 100,000, people that have purchased between 5 to 10, people that have purchased less than 1,000, less than 500. By the time you do that grouping, you can, so in those cases, since there is no target, it is supervised learning. So if you look at what we have here, you can see supervised learning talking about category or quantity, and then breaking it down and the likes. So this is just to give us a mental view of what this is. And let's look at the next one. So machine learning algorithm is the backbone of machine learning generally. When you talk about machine learning, it is the algorithm is what is making the difference. I'm going to, let me see if I can add any one of you as, I'm going to be adding one of us as a co-host so that you can help me accept people. Okay, I don't have that function here. Okay, I'll just manage this myself. So behind every machine learning model is the algorithm. That is what makes the difference. For linear regression, for example, it's popularly it's like equation of a straight line. The equation that I can call the algorithm it's just the backbone behind it. So what determines the type of outcome that you are going to be getting from your data set is the type of algorithm that you're using. So it is very, very important for you to use the right algorithm because that is what will guide decision making. For example, people tend to make this mistake with classification. There are some classification algorithm that can only predict that they are binary algorithm. But sometimes you see people that people want to do multi-class and they use it. If you use the wrong algorithm for a particular problem, it's just the same as you going to as playing a bet, because that means you are just it's like making a bet, and that is not recommended. We should always make decision that is explainable. Let's see what we have in the next slide. So now I just want to quickly talk us through the different types of ML algorithm that we have. Please feel free to let me know if you have comments, put a message in the chats, and yeah. So in terms of the machine learning algorithm, I think I have talked about supervised. I have explained unsupervised. For reinforcement learning is more around. Yeah, please, if you can kindly mute yourself, that would be helpful. Okay, so if you look at this, on this page, we have the different machine learning algorithm. For supervised, there is regression and there is classification. Under regression, we can have linear regression, multiple regression, polynomial, lasso, there are different ones. But the most important thing that you should know about regression is that a regression, you use regression algorithm when you are trying to predict a number. Maybe you want to predict, for example, you want to predict the credit score, or maybe you want to predict a percentage, when you are predicting a number. You use classification when you are predicting a category. There are some models that many of these models can go as regression or as a classification algorithm. In those cases, you call them regressor. For example, we have a random forest regressor when it is in regression, and random forest classifier when you are dealing with a classification problem. And unsupervised, we have clustering, and there are different categories of clustering. We have association analysis, we have reinforcement. Let me just go to the next so that we can see, learn more about these different categories. So if you look at this image is from V7 Lab. For supervised ML algorithm, you can see you have your input data. And for your input data, it goes through, you split your data into training, you have your training data sets. And when you have your training data sets, you have, that will be your X, you have your desired output, X, most times is your column Y, but that is the output that you're expecting. And then you plug your algorithm into it, you fit your algorithm. And when you fill your algorithm, it does the training, and based on the training, it will come out with the output. Okay, look at the left side. You can see under that raw input raw data, you can see the different types of data. You can see all the training data set belongs to a particular class. That is what we mean by a data set like that. We refer to them as a labeled data set, because they already have, we already associate them with a particular class. So after this training, based on the algorithm, based on having trained the model in a particular way using a particular algorithm, it is processed and able to output your data into those different classes. I hope we are all on the same page. I hope we understand this. So that is just a pictorial representation of how supervised ML algorithm works. Let's look at the next one, unsupervised ML. With unsupervised, you can see your raw data sets. This image, it looks like tablets, but I know it's not. So, but you can see the raw data. It wasn't, and in terms of the output, we don't have an expected output. So the label is, we have unlabeled data. So the algorithm picks up, okay, Anja, I'm going to be sharing the slide. We are going to have the slide at the end of the presentation. We are going to have the slide. We are also going to have a recording of this, so don't worry. So we have the raw data, and your algorithm is plugged to the raw data, and after processing, it comes out with predictions / outputs. So the algorithm helps you to segment the data. It generates the classes for you. So this is common. I've given example in terms of segmenting customers, and there are various use cases of unsupervised ML. And if we go to another class, there are so many classes when it comes to all this, but I've just picked up 3 major ones. For reinforcement ML algorithm, here you have an input raw data. For your data, there is going to be an environment. So when you have the environment, the model trains itself. And the way the model train is based on reward and punishment. When the model does something right, it is rewarded. When it does something wrong, it is penalized. So, and based on that, it continue and then come out with an output. If you look at the three algorithm, one thing is the unsupervised and supervised. At the moment, they are more popular. Reinforcement learning is becoming popular, but because it is creating an environment and having and the agents, currently it is still difficult to understand what the model is doing behind the scene. So although there are various optimization work going on in reinforcement learning and a lot of activities, but when it comes to developing critical ML infrastructure, there is still a lot in people still share away from using this model. Reinforcement learning at the moment is very popular for when people are making games. For a lot of games, they use reinforcement learning. But for critical infrastructure, like maybe in healthcare, you know, when the cost of mistake is huge, the use of reinforcement learning is still low, or maybe in aviation or in some other critical sectors. Choosing the correct algorithm for your problem. I think this is the main thing that we want to talk about, how you can choose the best algorithm for your problem. Generally, for machine learning, one thing is very, very important. You need to understand your problem and you need to understand your data. In terms of algorithm, we have a lot of algorithm. Apart from, we've talked about it, some major classes, but apart from classes, if you want to name them one after the other, we have quite a lot. But sometimes it's not every problem. One size does not fit all. You need to understand what is the problem? What does the user need? So the first thing that you do is you have your requirement analysis. So when you have the analysis, you understand data, then you can decide, is this problem a classification problem? Is this a regression problem? Is this a clustering problem? When you can answer that question, that is when you can move to the next stage. I want to quickly show you this. For those of you that you see, this kind of label, this kind of image is what you can actually use. For example, you can ask yourself, am I having a labeled data or not? If you have a labeled data, yes, supervised. If you have no, you can start gradually, you start to scale it down until you get to the data, until you identify the particular one that you want to choose. So for classification problem, as we said, the major thing in terms of requirement for classification problem, the label, most importantly, must be labeled. If sometimes it might not be labeled, but that means you must have a plan on how you are going to label it. There are, with the current development in machine learning, there are now ways that people can label their data. There are different techniques that can help you when you need to, if you need to manually label your data sets. So it is not, many of these things doesn't come, sometimes you might need to label the data yourself. So because your data doesn't have a label, does not mean that you can't apply classification. It might just be you need to identify how you label it yourself. Let me give you an example of where I have manually labeled data before for classification. Well, I should even use a popular one. There is a popular data set on Kaggle. That is the admission data set for a university admission in India. And one thing about that data set is that the data set gives it gives a column that predicts the chances of students getting to the school. And that prediction is between 0 and 1. So maybe 0.5, 0.6. So the way that particular data set is converted into a classification problem is by setting it a threshold. So when you set a threshold that, okay, if my output is 0.6 and above, return 1. If it is less than 0.6, if it is 0.59 and below, select 0. So with that, the problem becomes classification. And it is on this principle that we have a particular classification problem, a classification algorithm. For some of you that are familiar with logistic regression, that is the fundamental for logistic regression. Logistic regression is like a regression. It comes or it gives an output that is a probability out of 1. So you are allowed to now set a threshold. The default is 0.5, but you can always increase or reduce it. Thank you, Kavi. We'll see you next time. So you can always increase or reduce it based on how you want your model to look like. And then we have the regression problem, and then obviously clustering. So it's better for you to understand. Let's move to the next one. And then evaluating algorithm performance. After you've selected the model that you want to use, as I said, there are so many models, so it's not just one. So you now have to look at how this model perform. You look at how they perform against each other, and based on that, you can select the performance. And there are some common ways for you to know if your model has performed well or not. Accuracy, we call them the accuracy metrics. For classification, we have accuracy, we have precision, we have recall, we have F1 score. All these can be used to assess the performance of your model. Also, we have the ROC curve and the area under curve. That is most popular. That is very good for you to look when you're looking for true positive and false positive rates. And we also have the confusion matrix. The confusion matrix will tell you true positive or true negative, or those kind of things. All these ones that is here is for classification, but if you want to, sometimes you have regression, and for regression, you can use root square means and RSA, depending on what you are trying to track and your problem. Now we are coming to consideration for algorithm selection. For your algorithm, you will always have to consider a lot of things when you are making the decision. Here we have data size. Let's first talk about the data size and complexity. Let's assume you are trying to predict a number, but if your problem is complex, you might not be able to use just linear regression. You might need to depending on the way your curve looks like, you might have to consider complex model like maybe lasso regression or polynomial regression, and the likes. So your problem determine the complexity of the problem determines the choice of algorithm. So, but it is as a rule of thumb, don't make the problem difficult for yourself. Simple is always better. If you can do something with a less complex model, I recommend that you do that, because at the end of the day, we have some principles of responsible AI. And one of the core principles of responsible AI is that your model should be explainable. And when you use the model, the more complex your model is, the more difficult for you to explain what your model is doing behind the hood. And we have interpretability and complexity. So there's always I think I've jumped a little bit ahead of the curve there. You can see when your model is complex, you won't be able to interpret it as much. So there's a trade-off. You want to choose a model that is easier to explain. When you use a model like logistic regression, it's easier to explain. compared to if you are using gradient boosting or random forest. So you have to weigh it, you have to weigh those options. And then resource requirements. Your computational resource also needs a lot of concentration. For example, let's look at ChatGPT, that is the most popular at the moment. ChatGPT is trained with about, is it 7 billion or more data sets? And if you look at the cost of training that model, it will be very, very expensive. And because of that, it's not easy when you're training, imagine. And so you have to look at the costs in making your decision. So the more expensive the model is, the more difficult it will be, because it means that if you need to make a change or you need to retrain, you have to spend money. For those of you that have a ChatGPT account, you have to, if you want to use GPT-4, you have to buy credits, and that's one of the disadvantage. That's due to the fact that it's due to the resource. So trying to pay for the cost of resources. And then algorithm suitability for the problem domain. So even if you have resource and you have money, if the algorithm is not suitable for your problem, then you don't use it. For example, if your problem is maybe a linear regression problem, you can't use a language model that is used for ChatGPT. It just won't cut it. So you have to, the main thing that I think I should have put this as number one. The most important thing is that the algorithm that you are building, it should be a good fit for the problem you are trying to solve. And let's just look briefly at best practices. One thing that affects the quality of, after you've chosen the right model and stuff, and you've considered many stuff, there are things that still affects the model. Handling, and that is when it comes to data processing. As for machine learning, what determines the output is the data that you've used to train the model. And garbage in means garbage out. If you train the model with a poor or with a poor quality data set, you are going to be building a model that will provide poor quality prediction. So you need to take your time to ensure that you process your data in the right way. One of the most popular problems that we encounter in our data set is how we handle missing values. There are so many ways you can handle missing values. There are some methods based on the type of the data type. If it's an integer or if it's a text or string. One thing is important here. You have to carefully consider your data sets to determine how you will handle this. Because remember, each time you are handling a missing value, you are introducing a level of bias into your data sets. Because at the end of the day, the value that you are adding is not originally part of your data set. So you have to be careful. Sometimes there are people that handle missing data by maybe replacing with mean, replacing with median, replacing with mode. I think you just need to consider the data on its own merits. And also feature scaling and normalization. This helps to ensure fair comparison between variables. There are different types of normalization. There is minimum, maximum scaling. There is standard scaling. So it's advisable that you look at your data sets. Sometimes you can try various methods to experiment and see which one fits best with your data sets. For one auth encoding and feature encoding, this is used when you have a categorical data, you are trying to convert your data set into machine language. It is important if you use the wrong encoding method, it is possible that your data sets might feel that the label or some label is more important than another label. For some encoding, for example, when you put 1 or 0, the model might draw towards 1 and not 0. So you have to ensure that you use an encoding method that that doesn't introduce bias to your analysis. And now we are in model training and evaluation. In this one, cross-validation helps to assess model performance and avoid overfitting. What you do when you cross-validate is you spread your data, you divide your data into maybe 5 or 10, depending on the amount of data set that you have, so that each of these data set so that you have different models, and then you can find a mean in this model. What cross-validation helps to do is it helps to ensure diversity of your model across data sets. Because sometimes if without cross-validation, it is possible that during your train test splits, that a huge class of your data set can go to be test data that is quite different from the type of data that is used to train. So with proper cross-validation, it can ensure that you have your model is well diversified across stages. And there are other methods that you can use when it comes to the test train splits. There is k-fold that you can use to split your data sets. All those things help to ensure that you are having the best model. And hyperparameter tuning, that process helps you to optimize the parameters for the model and improve the overall performance. With that, you can do various experiments. There are different hyperparameter tuning method that you can use. There is grid search, and there is another one. So you should it's better for you to do this experiment, to try, because the more you try, you can discover what the best condition is for your data sets. And once you have, one thing about it is that when there's a change in your training data, which is likely to happen many times you introduce more data sets, you might need to do some new hyperparameter tuning. So it's good for you to do it regularly. The regularization techniques it helps you to prevent overfitting, and it's quite useful for logistic regression and classification. So it's good for you to spend your time in model training and evaluation. But always remember, even when you are doing your model training and evaluation, the foundation is on you making sure that your data is in the right state. I used to take photo, and one thing we used to say is that before using Photoshop, the best thing is for you to make sure you take a good photo. Because when you take a bad photo, thanks to AI, everything is now possible. But in those days, once you don't take the photo correctly, it's Photoshop and CorelDRAW might not be able to reverse anything. So, and then monitoring and maintenance. So it's good for you to monitor your performance and track it. You could monitor the prediction, what your model is predicting, so that because over time, your model or the performance of your model will definitely drop. And the reason why the performance of the model drop is that your training data changes with time. Imagine your customers, events in the society can affect customers' purchasing power. When maybe economic of currently we are facing high cost of living crisis. That high cost of living crisis might affect how people buy stuff. So all those things affect the model as well. So you need to monitor and track performance. If needed, you need to introduce new training data to ensure your model is up to date and it gives the best performance every time. Last month, we were talking about observability, and one of the things that our speaker talked about is handling data drifts. The challenge of data drift and techniques for Adapting models to changing data distribution is huge, and it is very important for many of you on this call that I know you are doing this for the first time. For now, these are things that you worry about later. For now, if you focus on the initial aspects of preparing data and understanding the model performance, because to be honest, in most of your first job is going to be around preparing data. 80% of activities in data science is about getting data, because our data is messy and it needs a lot of work. So in conclusion, I would tell you that today I have talked about the different types of machine learning. 1 second. So today we've talked about the different types of machine learning algorithm and their application. I've talked about when is best, the importance of selecting algorithm based on the problem and also based on data characteristics. So I have highlighted the significance, the best practice in data processing and in training and monitoring your model. And I've also talked about what you should consider when you are choosing the model. All these things will help you when you are asking yourself that question on which model you should choose. Questions around which model you should choose is a question, is when you ask yourself that question, it's not because you are new to this. It's just a question that you will always have to ask yourself over and over, because every problem, there are countless of scenarios for machine learning, and this is important for you to choose the right model. So I am not seeing questions in the chat, but if anybody have question, feel free to unmute yourself and ask your question. Or if it is just that you like to make a contribution. Yeah. If there are no contribution or question, before saying thank you for coming, I want to inform you that I'm recording this session, and I'm going to be sending you a record of this. If you need, you can always watch again or listen again. I believe what we've done today is useful because it's a problem that we always have to face at every point in time. Next month, there is going to be another event like this. Next month, I'm going to repeat. It's not like a repeat, but a few months ago, we did use ChatGPT to analyze data. But next month, what I'm going to do is I'm going to bring a new case study, and we are going to use ChatGPT to build, with the assistant of ChatGPT acting as a co-pilot, we are going to use it to analyze data, explain the data set, and then use it to develop a machine learning model. We'll use ChatGPT as a co-pilot to do feature engineering. We are practically going to do everything a data scientist do with the help of ChatGPT. The reason why I'm going to be doing this session is that many people are afraid of ChatGPT. They thought ChatGPT is going to replace data professionals, but no, the people that is going to replace you are the people that knows how to use ChatGPT to improve the performance, to improve the quality of their work. So the reason why we are going to be doing this next month is to ensure that you keep yourself updated with the latest trend in the industry. And as we know, almost every Microsoft tools now have AI plugin into it, especially the ChatGPT 4. So it's just to make sure that we are not left behind and that we continue to move in line with our profession. If you are in data, you continue to learn every day and you continue to develop. If you have any question to ask, please feel free to ask your question. Feel free to send me a message. Drop your message on our on Meetup group. We have a Slack group. We have on Slack. You can also drop your message on Slack. And if there are no questions, contribution, or talk, thank you very much for joining. I can see some of you that you've always been joining us regularly. I can see Odunayo, I can see Teresa. So thank you. I'm familiar with that. I'm familiar with those two names as coming back. And of course, to all of you that you've joined us today for the first time, it's nice to have you today. Have a nice week and enjoy your summer period. Thank you, Gary. Thanks, Fraser.